Okay, so in this video we're going to define what we mean by a group and run through a few examples to illustrate this. So a group, and we'll call it G, with an operation. So this is why this notation is used. So a group, G given operation star, is a non-empty set. A non-empty set. That just means that the set G that we're working with has to have some elements. If it's got no elements in it, then all this is just so trivial and doesn't make any sense. Binary operation. Star. Of course, this can be called anything. I've just said star because that's what's in here. But you could, this binary operation, when it acts on G, satisfies. So satisfying. And there's four axioms. So the first one is to do with something called closure, G1, and that is that if we take x in G and y in G and apply this binary operation to them, we're still in G, okay, so we get another element in G. So that's for all x, y, and G. That means we can't leave the group by using the binary operation. Okay. Next axiom 2 is associativity, so that is the x multiplied. Well, I say multiplied, this could be addition to or any other operation that when applied the binary operation y equal to x star y star z. Okay, so that's just about the order that's applied, and that is all x, y, z, g. Okay, the third axiom is to do with inverses. So, no, for identity, sorry. There exists, we'll call it EG, such that x applied the binary operation on EG equal to x equal to EG with the binary operation applied to x. And note in general that this swapping the order of the elements doesn't have to be true. That's not a necessary condition for a group. We don't need that property. Okay, but for identities, this is true, and this is some element. When we multiply it with any element, for all x and g. Yeah, when we multiply by any element, that element remains the same. So for multiplication on the real line, that would be the number 1. For addition on the real line, that would be number 0. Example. The final axiom is to do with identity. So for all x in G, there exists y in G such that x, the binary operation, x and y with binary operation star is equal to identity is equal to y star x. Okay, so this is again what we're familiar with inverses if we're talking about the real line apart from 0. Then the inverse of multiplicative inverse of 3 is 1 over 3, because 3 times 1 over 3 is equal to 1, which is the identity. Okay, so we're going to take a look at a few examples. And what we're going to do is I'm going to define a set with binary operation, and we're going to check if it's a group or not. Okay, so let's take the integer z with respect to addition. And if you are studying this, the questions you can be asked is to check things as groups. So let's if we think about the integers, so this is the set coming in -3, -2, -1, 0, 1, 2, 3. If we add up any two integers, we get another integer. Okay, so that's true. The next thing is if we add up three integers, so if we do x plus y plus z, that's equal to x plus y plus z. Yeah, so that's the second axiom. And then we know that for addition, if we take 0, then x plus 0 is equal to x is equal to 0 plus x. And then finally, for x, if we just take y equal to minus x, then x plus y is equal to 0 is equal to y plus x. So the integers with respect to addition is clearly a group, whereas if we take a look at integers with respect to multiplication, well, if we take, say, 2, we know the multiplicative inverse identity on the integers is 1, but 2, the number we have to multiply 2 by to get 1 is 1/2, so that equals 1. 1/2 is not in the integers. Okay, so we can't find an inverse in the integers. The integers with respect to multiplication is not a group, and if you do get a question asking you to show something that's not a group, you only have to prove that one of the axioms doesn't hold. To be a group, you have to satisfy all four of the axioms. I'm going to explore some theories that we get, theorems with groups, and some more definitions of different types of groups, and we'll explore some nice examples of groups in the upcoming videos. If you do have any questions on today's video, please be sure to let me know down in the comments. But that's it for now. If you did enjoy the video, please be sure to like, subscribe, and I hope to see you in the next one.